Today's first keynote session is by Mylswamy Annadurai. I hope I pronounced that correctly. Or what's so-called Moon Man of India, distinguished space scientist. He will talk to us about engineering India's space dreams, a journey of innovation and impact. But let me first tell you a few things about him. Dr. Mylswamy Annadurai, known as the Moon Man of India, is a distinguished space scientist and Padma Shri awardee. He served ISRO for 36 years, contributing to 60 satellites, including Chandrayaan-1 and Mars Orbiter mission. Um, I hope you remember that a couple of years ago. It was great. He held various leadership roles in ISRO and international forums. He has received numerous awards, including the Padma Shri Award for Science and Technology in 2016 from the Government of India. His achievements are featured in Tamil Nadu's School Board Science textbooks. After retirement, he mentors engineering students and young entrepreneurs in innovative projects of social relevance. And that's a short version of his huge CV. So I would like to call Dr. Mylswamy Annadurai on stage. Welcome. It's an honor to have you.
Yeah. Thank you very much for a nice intro. Now coming back, the topic, whatever I'm taking today is engineering India's dream, space dreams, a journey of innovation and impact. That means everybody has the right to dream, and as a nation, India is also dreamt to do something big. That means a dream to do something big, and having dreaming alone is not enough. We should engineer it to have navigate to a innovative mode, making a meaningful impact. I think this is a particular way I'm trying to cover this. While doing it, it will come as basically like a story. Hope you're able to see my next screen, wherein I'm trying to touch this as a twin story, being the keynote address, Engineering India's Space Dreams, a journey of innovation and impact, wherein individual is there and organization is there. How the dreams are navigated through and how it has claimed to be innovative and what is the impact it has made for the overall societal impact point of view. I think this is what I'm trying to cover. To take it up, ISRO started in a very, very modest beginning, birth of Indian space program. You talked here, it was a makeshift arrangement of a church in 1963. A very, very modest sounding rocket was made, the first ever modern entry into the rocketries for the Indian space program is concerned. That too, some sort of bought out systems from US and USSR and France type of thing, putting some of the scientific instruments in the system. The high altitude sounding rocket has gone. This is the first ever time this has gone. We can tell it is a birth of the Indian space program like that. Then gradually, it's an experimental stage of the launch vehicle, the satellites, very, very modest beginning, but still gradually, it has keep on improving, progressing. But then there is a stage where it is from experimental to operation, it has to graduate. At the time, he had some sort of a stumbling block came to ISRO in terms of basically look at here, IT boom has come. So ISRO was struggling to get the people in and retaining the people money. Then such things happened. So, but that time requirement also more, but some of the issues came within the organization. But overcome by that with an innovative approach, and then it was an exponential growth. If you look at that, the exponential growth, taking all the way to the mission to the moon and Mars. Notwithstanding that, initially it is bought out right from NASA to the sounding rocket. Only the geographical location is that place. But now you look at here, one of the costliest spacecraft ever built for Earth observation, in collaboration with NASA. NASA ISRO synthetic aperture radar. The full satellite was done in ISRO, and equipment sharing is happened from NASA and ISRO is concerned. And the launch of the satellite took place recently in 2025, another few weeks from now. A long things happened, and the process, a good number of even the foreign satellites launched from Indian soil, from the Indian rockets. Many things gave happen. So it is indicating, though there is a starting was very modest, and gradual increase, offering about some building blocks board. So what is that innovation and how it impactful has come is the story we'll talk about. That being the story of ISRO. Now I told a twin story. The twin story is another individual. The individuals probably will have to come to know who is the individual. The individual also, his primary school is a very modest. Some of the places you may try to, it will be difficult to believe also. This is a makeshift arrangement. The classroom is nothing but a cow shed. Every morning you have to go and take the cow out and give it to the farmer for him to for the thing, and then clean the system and make daily classroom in that place. I think that's how the primary school of this boy has happened there. And gradually things have moved, and then a modest building called school also came. I think this was happened to the thing, completing the primary school is concerned. From that primary school, coming to the then going to the college is concerned. I think some of you may be in that stage now. Then which way to go, whether go to arts or science or emerging field. That time it is very few colleges were offering engineering. So whether to go that way, I think this sort of crossroad I was there. So then I had the inclination, because I used to score good marks in mathematics and science, and some sort of a practical oriented thing, doing a toys and trying to understand. Many things happened there. Putting the things together by the science and as well as applied science is the engineering. So I took it to the engineering and engineering college, undergraduate, postgraduate, PhD, like that. It was keep moving forward. So with this, then I graduated. Then I joined ISRO. 1982, I joined ISRO. And for me, progress also is reasonably good, but it is a slow progress. Until a place where I told, in ISRO, where there was a point that the ISRO was struggling to overcome that, but it came with very innovatively, and afterwards, no looking back. I think that 2 points used to join around that point. How it joins, how it moves is a subsequent, you could also see. Then subsequently look at here, like ISRO also, this individual also has a grow, okay? Within the organization, with the career wise, the social status wise, very many things happened there. And even beyond, after my superannuation, I think I had a fairly good amount of activities across India is keep happening. Today, I tell this as a story to my grandson. Okay, that means when I started the school, so-called formal STEM education was not there. Formal, of course, STEM itself being coined somewhere around 2000, early 2000 only. But today, my drawing room, we talk about the STEM along with the grandson. I think that is the thing which has happened while this journey of individual has happened there. Now, taking the story slightly different perspective. After college, an enthusiastic graduate, I came out. So then I was running around India, because India also was emerging, various forums. But I was not very much particular into IT. I wanted to learn core engineering thing with a lot of dream I was going around. But somehow or other, I was not getting the job what I was looking for. I told the dream, no, you have a dream, but the dream to attain the dream, something you expected in the wherever you get the job, but that was not coming there. So I became a confused and frustrated youth. I think now I used previously a boy, but now I'm telling I think now you could understand what does that mean. So I became a confused and frustrated youth, and with this thing, I appeared interview for ISRO. Okay, and then I got the job in ISRO also. And ISRO 8 is also looking like this. Though it started a very humble beginning in 63, one and a half decade later also, it is not very much improved with respect to infrastructures, the way in which working style is going on, also looking like this. So it was looking like that all along across India. I've gone through that. I'm not getting a dream job. I thought something I'll do it in within Indian Space Research Organization. ISRO means Indian Space Research Organization. So space is definitely a place where you will have a lot of dreams. Uh, Probably you can fulfill like that you join, but it was not. The place was looking like this. It was a really big question mark. What I'm going to do like that. But at that point of time, again it came back to me. My beginning of the school, starting of the school, was very humble beginning, a cow shed. But that didn't stop me to get a graduate or postgraduate or get doctorate in engineering. If that is the case, why the place ISRO at this stage, at this mode, should stop me to move forward? Is it possible to do something even with this thing? That means with the available resources, what best we can do, like that, that sort of thinking came. So that translated just 2 weeks into ISRO, a suggestive note for the software satellite simulator, because we are not making the satellites by the time. Satellites are done by elsewhere and launched by elsewhere, and predominantly ISRO was trying to maintain the satellites done by other countries and launched by other countries, and as per the manuals of that. So this suggestive note was given to then director ISRO Satellite Center, Professor R. Rao, and he gave back within a day, good, do it yourself. So that was a real tipping zone for me. Because that means there is a people are trying to recognize what you appreciate what you have done, and trying to give you a responsibility of to do that. So, okay, so that it translated into a really 4 years of hard work to come out with that. That means you are beyond what you have learned in the college. You have to understand the nitty-gritties of the satellite system, interplay of the very engineering aspects, and its flight dynamic systems and its orbit. Very many things you have to understand, and trying to put them into a mathematical form, mathematical simulation, and translate into a software code into simulator. I think all in you have to do like that. So the first ever satellite simulator by ISRO was built around that time for the India's first remote sensing satellite, IRS-1A. I think this is how my work started. So then as ISRO was growing, I also was keep moving forward. The point has come. You can look at here. Basically, I'm trying to navigate the journey, how that innovative is happening, how impactful also coming. So probably you will able to map it down the line, every one of individually also. This is more like a template I'm trying to put it here. So now satellites indigenously, locally, India started making satellites. So, but now already you are comfortable in making the software satellite simulator. So between comfortable zone versus to a new arena going, are you ready? Like that thinking came. The option, but rather it came to be. So I took the next side instead of being comfortable zone, move forward and go for the hardware making. Of course, softwares are there, but it is the full system making for the communication and remote sensing satellites are concerned. So that's over the decade, you look at here, being a self-reliant and self-sufficient. Those started very modest that way and trying to learn experimental this way. So now slowly we are trying to get a good number of the satellites being done within India, and as part and parcel of that effort is concerned. So by 2004, this is a time frame where I told now where some stagnant point is coming there. At that point of time, yes, I personally I was in a very comfort zone, making the satellites just asked for and launching it and operating it, a reasonably good comfort zone. And you also stabilized within your career, and like that sort of thing happening. Almost similar thing happened to the organization also. By 80s and 90s, you look at here, a good number of satellites for communication and remote sensing was given. And it was, though it was started at the modest beginning, and we have our own satellites, our own launch vehicles. And moving ahead, satellite manufacturing to be national demand in a big way nation was asking for. I think that's how we're looking for. But at that time, we had the issue, whatever I told there. ISRO was finding it difficult to retain the people within the organization, and new recruits, new talents also ISRO was finding it difficult to attract the new talents. But the requirement now, the thing is, the people who are already trained are going out, and the people who you want to additionally you require to make the satellites and launch vehicles to be done there. Government of India wants, and for that you have to recruit the people, and ISRO was finding it difficult. At this time, what is to be done? I think it's a lot of brainstorming things happen, and that brought you some inspirational mission to retain and recruit the people. We need something inspirational within the organization. Like that, it came. What is that? I think that's the thing happened. This happened not only for organization, the individuals also. Individual also need to be retained within that. You need an inspirational mission, and that's how the mission Chandrayaan, mission to the moon, came out, and the crossroads. That's what I'm putting it. What I'm putting it here. So, as an individual, also I am in the crossroads. So you are already making satellite being your comfortable zone in the national satellites are concerned. Private sector sitting in the Bangalore, it's a pensioners' paradise. People will tell within in India, the climate, salary perks, and many things are concerned. And my organization itself is in Bangalore. All putting together, a good number of offers came from the private sector. So whether to do like that, it's came. At this point of time, organization is thinking to put an inspirational mission, and that the chance of me getting into that mission came there. So whether which one to take, I think a lot of thinking gone there in the crossroads, whether to be in a comfortable zone within the organization or go to the private sector or take a new challenging opportunity of Chandrayaan mission to the moon. I think that's what came. So though it's an inspirational mission to the moon, but many people already gone to the moon. They landed the moon, brought back the samples. Many things happened there. But now you are starting with a project report, and the project report is a very reasonably good thing for Indian government for the overall financial and schedule point of view, technologies readiness point of view. But this question mark came. Yes, we can make a challenging mission for within India is concerned, but how well it will do better than what already missions have done elsewhere. And that question mark came. So that calls for another crossroad. Even though the project is a new, we have got to the moon from India, but elsewhere people are already gone. But what difference you are going to make in this that came? So that calls for another cross thinking. That means you have to make a creative strategy beyond what you thought about, what you capable of, what your budget can do, what your team can do. Something else you should do, or else you also become also a rankers rather than you make really to inspire yourself and inspire the nation. Like that, it came out. So what is to be done? Again, the question mark. That question mark was to go to the further into that unraveling that mystery. So we are looking for why, what really the lessons learned from there. 50s and 60s and 70s. What are all the how many missions have gone to the moon? You look at here. A peak was there in 60s and 70s and 80s and 90s. People stopped going to the moon because moon was declared as a barren. I think this is the one of the reason why even the competing USSR and the USA is competing to go to the moon and landing on the moon. Many things happened there. But in 80s and 90s, when we are talking about 2000, I think around that time missions to the moon stopped, and Mars and beyond was thought about because moon is declared as a barren. So in this background, India's venturing there, is it really worth? Question mark came. So when really go into that, why they declared moon as a barren? Possibly, they land on the moon and search for the chemicals and including the water, and that's the one. Probably could have given the answer like that. That means wherever they landed, wherever is seen, probably the answer would have been correct. But somehow or other, we felt the whole moon is not fully explored. Okay, possibly around that time frame, whatever the instruments are available, like that. But now you look at here, when you're talking about around 2000, a good number of remote sensing systems have come. India itself has graduated one of the finest constellation of the remote sensing. So putting the things together, probably you can redefine the mission different way if you go to the moon. That means search for the chemicals using the first mission, the whole moon, the global search for the whole moon. So then you land on the moon where you feel your data tells is a fertile. I think that probably may be the real answer like that. We wanted to do that way. Okay, that way we can do like that. But still the capabilities of, for example, you compare NASA versus ISRO. What using NASA used launch vehicle Saturn, the very heavy lift launch vehicle. But at that time, ISRO didn't have even GSLV. It's only PSLV, Polar Satellite Launch Vehicle. It cannot take, for example, typical orbit, if you talk about that, Saturn can put somewhere around 140 metric tons of a thing in a low Earth orbit. But whereas PSLV cannot put even 4 tons, it cannot put. So, okay. So this is a vast capability differences sitting there. With this, still, is it possible to go to the moon? I think engineering, when I talk about engineering the dream now, so engineering point of view, these are all the questions came. How then, what is the way you are able to go to the moon? Again, when you study that, using the certain heavy lift launch vehicle, that is possible to go to the moon at one shot. That theoretically it's possible, and that repeatedly they did it also. But PSLV cannot do that because its capabilities are much less. So it calls for another ingenious way. An engineering solution has to come there. So that came out like this waste loop configuration, wherein the PSLV at the maximum can give 22,000 kilometer high elliptical orbit from the Earth's point of view. That means 200 by 22,000 elliptical orbit can go. From there, incrementally, you have to keep improving the orbit of the satellite using the satellite provided propellant in optimal way. So that way you can go and again go over the polar region of the moon. So that means you acquire around the polar region of the moon. Previous to that, not many missions have gone to the polar region. That means this calls for global, that means the entire moon to be remote sensing way to see using a good number of instruments. You should go for the go the lunar polar orbit. I think that is also a engineering point of view challenge. I think that's what we should do, like that we planned and we have designed the mission. Still the question is, ISRO's initial configuration of the mission, with that if you go, yes, probably, even if tell, assume, even if you tell ISRO discover something, to consolidate, to confirm that, okay, you need, if you have somebody else also along with you, if your instrument also discovers and their instrument also tells, then the confirmation will be scientifically will be much better. I think that's got thinking process has gone. So that opened it up a new bringing. ISRO will carry 6 instruments, and some instruments can come from other side or from outside India. Like that, announcement of opportunity was given. To our surprise, good number of instruments came because nearly 3 decades people have not gone to the moon. So a lot of people waiting for an opportunity, including NASA. Now, okay, European Space Agency, JAXA, like that, many scientists came. And initially, we thought we are looking for 1 or 2 instruments, but so many instruments came. Then our team sat together and how we can maximum systems we can put an engineering optimization of very many things happened, and the satellite configuration got changed. That means the satellite configuration is much more sophisticated than this, bringing in so many instruments. That means around 12 instruments carrying to the moon to have systematic mapping of the entire moon. Look for what moon contains, every inch of it. I think this is how the satellite configuration was reconfigured, putting all the things together. Now ISRO is getting the mission, but other laboratories will be joining. So with this, I put it the mission into the International Lunar Conference. That conference was chief guest of the conference was none other than Dr. Kalam, my senior colleague, as well as he was by the time he's the president of India. He told, yes, the mission is good. Your project report has come well, and it has a good number of instruments, and you will be able to unambiguously tell what moon contains. This mission possibly will be able to tell with all the wisdom of the entire globe, the best of best minds of the globe for the lunar science with you. You will be able to do that. But in case your answer also will be a barren mission, moon is a barren. So then even though scientifically it's success, but people will not take it where. So is it possible for you to carry in the first mission itself, such that to touch the people's sentiments, such that Indian tricolor flag, national flag, also somehow it goes to the lunar point of mission first itself. I think that's why, because polar region going for a national flag has never happened for any country that time. Armstrong has landed in the near equatorial regions. So that's how he put the requirement that way. But that requirement is putting simple, but translating into engineering way is a very tough situation for me. Again, it put me into crossroad. Because I cannot decide along with my team. A team of engineers and scientists are there. With the lot of team discussions went to that. That means approved project was very, very modest. Yes, we can do that with that. Now, updated project, it calls for so many instruments. We have to accommodate them within the schedule, within engineering thing. A lot of automation is called for. Now, Dr. Kalam is asking to somehow you make the one national flag to reach the moon. So if that calls for a lot of iterations, and accommodating everything as a one mission is a very, very tough situation. People told you select either one or two or three. Not possible to have all the three together. It came. Then it calls for a lot of iteration, lot of thinking, lot of simulation, lot of engineering discussions went through that. But somehow I thought I should take it 1 plus 2 plus 3. I told now navigating an innovative way. That means 1 plus 2 plus 3 within the project scope, within the say, budget, within the same schedule, within same PSLV. We should do it everything three together. So that I think it took a lot more things, but it called for a lot of, because now you look at it across the globe, your partners are there. Engineers from NASA, yes, West Coast, JPL is there, John Hopkins University is there, we have JAXA is there, UK is there, we have Bulgaria is there, we have Germany is there, Japan is there. So very many countries together. Even in 2000, this I'm talking about early 2004. Okay, internet is not that much there, but with the whatever the rates available with that, we managed to have the engineering discussions, optimization. So keeping all other constraints same, launch vehicle remains same, budget remains same, and the schedule versus system. Yeah, so like that, we have gone that it called for a lot of iterative thing and the simulation mode. It has gone through that. So it is more like a war game like simulation we have done within that during that period of nearly 6 months to 7 months is concerned. Finally, very compact. The satellite configuration has come like this for ever. The first ever time you can see that for the around the moon, this many missions, 22 units along the apart from the satellite system, carrying to understand to unravel the mystery of the moon. I think it has gone there. That means visible spectrum, infrared spectrum, UV, hard X-ray, low energy X-ray, like and even your microwave, like that various spectrums of the instruments to do the remote sensing of the entire moon has gone there. Beyond that, we carried a wikibag system at the top of the satellite that, along with the tricolor flag, will go and impact on the moon. Okay, so that way, impact the tricolor flag also will go, but other instruments also will do the real remote sensing originally planned. A very innovative thing. So for this, for design itself, the Chandrayaan satellite garnered 2 international awards. So this is how the satellite was configured. So this now gone to the moon as originally planned, with all the engineering aspects, whatever we have done there, incrementally improved. Originally planned 2008, October 22nd, launch took place, incrementally improved. After reaching 100-kilometer polar orbit, a piggyback system was thrown out, and that has a small micro thruster that will fire and remove the orbital velocity to the extent of 75 meters per second. So then no longer it can be in orbiting. So mothercraft will go on the orbit, but whereas this piggyback system is keep falling. While this keep falling along with the tricolor flag, but not only the tricolor flag, that also carried 3 instruments, including a mass spectrometer. Okay, and the mass spectrometer is in case in any low volatile elements like water it could have been there. That's supposed to get evaporated. That's supposed to generate a so-called tenuous atmosphere. All along we thought moon doesn't have a defined atmosphere, but in case if it is there, that will generate an atmosphere during the daytime of the moon. That's what our conjecture. If that is there, this mass spectrometer will sniff through what constituents that atmosphere is made up of. From there, trying to understand to first signature of what the surface of the moon contains. I think that's how it then there. So up to from 70 kilometers falling up to 100 kilometer to 70 kilometer, we didn't see anything. Afterwards, we started seeing the signature mass number of 18, keep pronounced there. So that indicates the presence of H2O. Mass number 18 was H2O. So then systematically other instruments, IR instruments also trying to do and try to see that. And you look at here, the latitudes, especially the high latitudes, we are able to see this signature of H2O. That means IR spectrum, it's going, and it's even low latitudes, we are not seeing anything. But when high latitudes, there is a dip is happening there. This absorption, that means solar radiation comes and that reflected back indicates the presence of water OXL molecules. So that this is the signature of around the 3 micron. The dip is happening there. This is happening around this. So this is once again substantiated with another instrument. The presence of water molecules on the surface of the moon is concerned, higher latitudes. And if that is, and by the time we have another satellite after our discovery, with a long gap, US launched another LRO mission is launched there. So along with that, we made a coordinated experiment. First ever time, very, very innovative coordinated experiment. The 2 satellites making around the moon to look at the polar region of the moon and to quantify if any ice is there. If ice, the form of ice water is there, I think that's how this has happened there. And that also we are able to see that. So effectively, we are able to come out with the water map of the moon. So you look at the polar regions where the ice is seen, and what here we are water molecules, whatever we are seeing at higher latitude. This is the thing happen. Why that happens? Definitely, looking back in my village, what I used to see when I was a young boy, in the lake, a very big sprawling lake of 400 acres. A big lake used to be there in my village. In that village, when the moonlight comes, actually, until my age of 10 or 12, my village didn't have even the street light. So we used to play in the moonlights. The moonlights, we used to see the reflection of the moon on the lake. So when in our lake we are able to see the moon, how the moon will not have water, people will tell. I think I used to, a child is an innocent question I used to make. Now the answer has come. Possibly I also instrumental to get that answer 40, 50 years later. Just I'm trying to correlate this in this view graph. So not only that, finally, after subsequently, you look at here the sodium map and magnesium map, type of many things happen. And it includes very, very many things, including the 3D map, which better details also came. So that for the subsequent landing missions helping for that point of it happen. So when this happening there, we started moving for the Chandrayaan 2 orbit point of view. So January 2011, Chandrayaan 2 orbiter is ready, and final integration and launch, we are getting ready for that. When we are engineering, some other innovations come for that I'm putting. So February 11, this mission, Russia was our partner, and Russia asked for a change request by the partner Russia. But that created a big, because 2011 almost we are ready with the configuration. Team is very enthusiastic. Yes, we have done it. Waiting for the part coming from the Russia, but they wanted a big change in our system. So that created a lot of work within the system, because that whatever the change request asked for, it makes almost the system cannot be used for to go back to the moon along with Russia. Such a situation it's happened there. So we are in a big dilemma again in the crossroad of what is to be done. Like that, we are sitting there, but this man jumps, looking at golden opportunity. That is nothing but looking at the Mars. Okay, that means without suspense, what is happening is, instead of putting this orbiter around the moon in Chandrayaan 2, why can't this hardware to go to the Mars? I think that's how that whole thing came. But that statement, to make it reality, it calls for a lot of engineering simulations. So exhaustive simulations, whatever the simulator I have done initially told, that has been improved upon. And I can run Chandrayaan 1, how we selected orbit. Now we are going for the Mars mission. We are doing a lot of exhaust simulation, and with that, improved autonomy if you bring in, I think that's also possible. That means autonomy, and we is talking about artificial intelligence for that mission at that time itself. So that way, we came out to the thing. Yes, it's that hardware which is made for Chandrayaan 2, still it can go for Chandrayaan Mars itself, configuring this way. Like that it came. But it's an incremental improvement, innovative approach, incremental improvement. That means you launch it there and incrementally keep improving, like whatever Chandrayaan only have done. But last leg alone, give an additional velocity, particular time, particular direction, and particular quantity. If you give, that goes away from the gravity of the Earth, but acquired by the gravity of the Sun. So like Earth is moving around the Sun, Mars is moving around the Sun, Mangalyaan, Mars orbiter mission also move around the Sun without any additional energy is concerned. So that, but such that you should do that. You travel after 9 months later, when it is coming over here, Mars also, which is orbiting around here, will come and catch there. So there autonomously, you must be able to reduce the velocity to some extent, such that it will be captured by the gravity of the Mars. I think this is how the mission is configured, and almost no additional cost, additional energy. This has done. So this is again the simulation, and this is the way it has gone also. And incrementally and incrementally keep improving it there, and make this last attempt. You make it's one slightly more kick, as calculated, as originally predicted that time and that way. That way, if you do, now you look at here, as I told, around the Sun, three objects are going. Two are already natural system. One is a man-made system going around the Sun. And this travel is nearly 9 months. 2013, the launch happened. 2014 of September, it was coming nearer to the Mars as expected. When it came, then by the time we, yes, we build in a lot of autonomy, we build in when in the course of when the travel is concerned, such that from here to from Earth to Mars is concerned, nearly 20 minutes of the communication delay is there. So within that, we cannot do a real-time operation, but it was autonomously it was done there, and it has acquired the satellite around the Mars. When it did, Prime Minister of India was behind, yes, clapping. The whole India was clapping. India has become the first ever country. ISRO has become the first ever organization to succeed in the first attempt itself. I think that for the Mars, using a hardware which originally planned to go to the moon, it has gone to the Mars. That's how we have done. This is very innovative approach. Now, these are all the things we are telling to inspire the people retained within the organization, to attract the people from outside. Yes, that also happened there, because this mission helped us to inspire the people. So in that process, a good number of people came, and a good number of people be retained within the organization. And the government also gave good amount of support and budget. And to the date, really 125 state-of-the-art satellites for societal national application. That Moon and Mars is different. Beyond that, agriculture, energy environment, infrastructure, water management, development projects, so many navigation missions like that. Them beyond space commerce also. Okay, additional capacities of PSLV and GSLV utilized for launch of 424 satellites from 34 countries. This also happened there. That means the two inspirational missions have done its own job. Its own job. Not only its own job, commercially also, using the PSLV, we are able to go to the same PSLV only used to go to the moon or Mars. So that is a case that gives a very brand name for the launch vehicle, and commercially also become success. Beyond inspiring the people, it doesn't commercially also become success. That way, the navigation for Indian space trade, how it has navigated and how it has given impact is the one I'm telling. Just putting the things all together, social impact point of view, recently conducted a study indicates what its economic empowerment. Nearly 60 billion US dollars GDP is provision, and directly or indirectly, nearly 4.7 million jobs it has created. And the startup ecosystem is coming up very well, very big way within India. Agriculture and rural development satellites are helping in a big way. Communication connectivity, I think India is one of the cheapest data plan across the world. You can look at here internet pricing or cell phone pricing. In India is one of the cheapest across the world, I can tell you. When I think 2 days from now, I'm going to fly to US. Data plan there is costlier than data plan what I have sitting in my home or in my cell phone I have within India. So that thanks to the communication connectivity. Similarly, disaster management and environmental monitoring is doing well. Education, inspiration, scientific temper spaces and fantastically well. I can tell you that. A few graphs also down the line tell, because it has given people like me a face. And that also given to an inspiration within the educational departments are concerned. Beyond all these things, space plays a global diplomacy and collaboration. Space being used, Indian space program is being effectively used for the global diplomacy and the collaboration point of view. India's excess capacity being used for the developing countries, African countries, and Asian countries are being used in a better way. So that way, you look at here, that beyond the dream, that innovative journey has taken a very big impact. I can tell you what's happened there. Just to give one example of that is, you look at here, India and around India, the number of people used to die, people died in the 50s to somewhere around 2000. You look at here, a few thousands people used to die, hundreds of thousands. I think it is a huge numbers of the death. This logarithmic scale, you should understand this logarithmic scale is 100K. Okay, so this is the number of people had died during the cyclones during that time. After I told, no, after 2008, this when the experimental 2 operational has come, India started making its own meteorological satellites also. So these are all the satellites are launched after here. You look at here now, the number of deaths are not even 2-digit numbers. Okay, in spite of the fact the population density over the last 75 years much more than what it was 1950s. So, but the overall death point of view, drastically it has been reduced because we are able to give the forewarning. So policymakers are able to evacuate, take the things to that. So lives lost towards the meteorological satellite launch, he gives, yeah, how many lives saved. So instead of how many lives, this means this many lives saved, I can tell you. Okay, today lives death is this much. That previously it was like this. 75 years back, the same population density around the same place, much more higher there. So, but even though severity of the cyclones are high, today we are able to bring down this much. That means I can claim this much lives you saved there. So like that, the impact of the societal impact of the space program, beyond going to the moon or Mars, that's given inspiration. But inspirational missions are given back to the society in a much bigger way. Not only I told the twin story, so that story is not for the ISRO alone. The individuals also. I'm one among the individual. I'm not putting myself there. I'm one among the individual, but I myself after superannuating. So this means formal STEM education would not have been there for me initial stage, but into the ISRO, I think it has given education, whatever I learned there, it gave me ample opportunity to learn within the organization. That learning, he definitely helped me. Today, I am part and parcel of this many organizations. Okay, that means you're able to make a fisherman a kid, a telesurgery. I think today India is having one of the well-connected telesurgery system. Even for the cardiac surgery, we have done it recently. Even for 10-year-old, 8-year-old boy, it was done. From Delhi to Hyderabad, it was done very recently. I am part of the telesurgical systems is concerned. Similarly, green hydrogen, very many things. EVs is there. Drones is coming. It's there. Say startups, it is there. STEM education also in some form or other. I'm doing my job there. For example, 2 days from now, I'm flying to US. Is a part of the America India Foundation, which is doing a reasonably good job for the STEM education, digital equalization point of view. That means across India, how the digital divide can be connected. I think we are trying to do it. I like that. So many activities also going over there. Beyond ISRO, now outside ISRO, I'm part of that. That's a story. So I'm doing a good number of reasonably good time I'm spending for social service. Other things also happening there. Then I used to write the books and I used to speak also. Today, that's what I'm sharing some time with you. To the date, I have written some 9 books. Of course, it is the local language. Just to give one example, just run through that. My earlier age, my village used to be like this. When I started my thing, probably I started my schooling in a cow shed. But the village was very greeny, the lake was very good. But today, you look at here, India is, because of very things, starting from 340 million kitchen stoves to 40,000 steam boilers, a good amount of fossil fuels being used, and it is today. You look at here, the global warming is concerned. This part of the country also happening. It calls for definitely the solutions to be done there. Is it possible to do that? I think towards that, I think green hydrogen is the effort. I'm part parcel of that effort is concerned, wherein the boilers we are trying to reconfigure using the solar to uh, hydrogen conversion and doing it again. And the stoves also we are trying to do that. Similarly, I am telling about the robotic surgery, telesurgery and teleprompting point of view, because India needs, see, a country, a vast country, it needs so many villages, more than 250,000 villages are there, more than 1.4 billion people surviving there. And healthcare is beyond education. Healthcare is also equally called for. So it connecting the super specialty hospital and surgeons to the needy primary health centers, the nook and corner of India is called for connectivity. I think it's now today India's indigenously made robotic system, very much affordable cost, which fits into the government of India, government of states package, which can any poor man can get the surgery, get it done there. I think we are able to reach out there in a better way. And this is the thing, the team, whatever I am sitting telling, indigenous robotics, whatever we have done, and a good number of things have been being installed across India, and that effort also going on there. Um, so basically what I am trying to say is STEM education doesn't mean it should stop from the schools. I say lifelong education is possible, and you can be part and parcel of the STEM lifelong to keep. Even though my age is old, I'm feeling I yes saying yes there because of the activities coming there. Similarly, the STEM and space education, how we can connect it together, because of space is given multidisciplinary. So that provides the STEM education much better way to do that. I think we made some sort of experiments going on, integrating the space curriculum with the existing educational syllabus, starting from mathematics, physics, and the interplays of the things are concerned. And we are trying to do that in experimentally. And probably in the network, one of my colleagues would have talked about that. This is Academia and the CubeSat program. I think this is recently an experimental we have started from its Dubai campus. It is morely a stretched program over 3 years, how it can go, starting from a drone satellite launch and their own control center, doing STEM education, and finally they will be having their own launch. So this will be some sort of a course we are trying to connect it, and there the college will do, and nearby schools also will get connected there. In integrated way, we are making an effort there. And beyond that, I told that digital equalizer across India, we are trying to connect. I started my beginning, very humble beginning, but still I could manage and come back there. But now to my youngsters, whether anything better that we can do, I think they are making an effort. And how the digital equalizer is working is try to give some sort of a STEM education and the infrastructure within the schools are concerned. Today, we have done training the advanced STEM learning for the teachers, and equipping with the digital contents for the course content, as well as equipping with the gadgets, and even the capacity buildings you have done. So to the date, the cumulative impact is concerned nearly 8.1 million children have been empowered in that, and nearly 46,000 schools have been transformed to that, and nearly more than 240,000 teachers have been trained, and almost all the states and units have been covered. This is simple. You look at here. As far as among so many millions of students, 6 to 12 to student 12th standard, we have done that. So this model is being taken by the government, and that they are multiplying in a big number. So that's how it's happening. This is my school. I started my school, Litolda. This is my school where I studied, my alumni, I can tell you. So that is America, India. Through them, we have done the STEM Innovation and Learning Center. Today, my schooling 50 years could have been different, but the same place now, this is a STEM education point of view alone. This is not classroom, STEM education point of view alone. Like any laboratory, like library, like playground, and we are trying to provide for the government schools, public schools we are providing. This one such thing, what I am telling, among the many models, whatever I shown there. So this is the, yes, I see an impact. An individual has gone through the dream of Indian space program, is played a role in that. So that way, you would have seen when I'm talking here, Indian space program, which very started by the modest way, including the individuals who had a very modest education there, but still their dream was big, to do something big, and reasonably good also they have done in terms of space missions going to the moon or Mars, as well as for the societal needs, and taking beyond that, use the space as the point where India can play a reasonably good role, even for the internationally also. As a player of for the peace loving, as a player to make the green world, I think definitely India is doing well. And the individuals like me also is a part and parcel of that. And we are not only alone, and we are trying to see to that the next generation also takes this cue and doing it well. For that, we make all our effort there. So that means Indian space program is all about how you can make it a cost-effective way, how you can make it impact the society, how it can take the image of the nation, pride, inspiration. I think very many things. So engineering India space stream is a journey of innovation and impact. I summarize it like this. So time is over. If questions, anything is there, I am available. Thank you. Thank you very much.
Yes, Dr. Annadurai, thank you so much for your presentation. I do have some questions. We've got a lot of activity in our chat, and so I'm going to go ahead and share some of those with you. We only probably have a couple of minutes, but I think that's fine. I think you can really cover some ground with those. So the first one is Dr. Annadurai. Hang on one second. What advice would you give to young engineers who find themselves at similar crossroads when deciding between research, industry, and innovation pathways?
Yeah, basically my idea itself to put myself in their shoes and try to show that. Basically, I was good at mathematics and science. So then, instead of pure science, it's applied science I was looking for. So that's how I took the for engineering point of view. So my suggestion is you align with your ambitions should be aligned with your skill sets and what you like. I think these two you match it. I think. That's a good. Whether you want to go to the pure science or for the applied science, it's okay. But as far as I'm concerned, today applied science is doing reasonably well. Being an applied science, you can do a pure science also. Possibility exists. For example, lunar science is basically a basic science. But towards that, we are applied science people have helped a lot. Putting instruments, putting the satellite, putting the things, and rewriting the lunar science totally different way today. I think that's happened there. So my bet goes with the today's condition is concerned for the individual as well as the nation's applied science. That means engineering is a better scope.
Great. I got another one here. I'm going to queue up. So what is the single most challenging part of the training and beyond being a test pilot? What personal qualities is ISRO looking for in its first nauts, the selection process, basically?
Yeah, ISRO basically it is second. It's being the first flights is well, whatever happened like that. It is a test. The pilots are the test pilots who are in the Indian Air Force, who are well trained, and the creamy layer of that will be selected. And they underwent the trainings in the established organizations for the astronaut training. And beyond that, I think recently the commercially available Dragon vehicle. One of our astronaut have been flown and there, so that he's getting ready like that. So that way, the first few people will be from the test pilots of Indian Air Force.
All right. I think we maybe only have time for one more because our next session starts in about 10 minutes. So let me pop over another question for us. How have international partnerships influenced India's domestic space industry, including private firms, startups, and supply chains?
Yeah, as I told, I acknowledged also initial starting of our program is definitely the international collaboration helped a lot. That's how the ISRO's pathway, whatever roadmap, whatever I showed, it is there. But there is a transition. It's happened there. That from the transition, now you look at here, India is on its own. Today, it's on its own. But still, for example, the human face program is concerned, India relies on the international collaboration. So that again. The future, the possibility of the human colony, something like that. We are talking about lunar space. India advocates for the cooperation. Beyond that, I seen one question. So how India has been helped? India has been used its collaboration with the advanced countries with initial stage. Now India is offering similar thing for the developing nations. I think every year around 15 countries being through UN selected. I think I myself, when I was director, I proposed that, and that it came out. Every year we are selecting 15 to 20 countries who are non-spacefaring, and they are being brought here and they are given on-the-job training of how we are using the satellites, how they can be part of that. And that's going on for last 3-4 years. Last couple of years, it keep going on there. And then we also provide the excess capacities for them to make use, especially remote sensing type of thing, and navigational things and all. The excess capacity of this being allowed for the utilization of the developing countries. That way, India's path 60 years back, how India was hand-holding used by US and Russia. I think similar thing India is doing for developing countries as on today.
Very good. I think that's all we have time for. Thank you all for your questions. We're going to try to get them over to Dr. Annadurai after the event, and perhaps he'll be able to answer some of those directly to you. So thank you so much for your time and for your presentation today. We appreciate what you shared with everyone, and I know everyone was very excited for your presentation.
Thank you. All the best to the participants.